Okay guys, so we're going to do this little mini lesson on separation techniques, and just because it's a mini lesson, please don't think that it's not important. It definitely is. There's a lot more emphasis on it in the objectives now for the AP test. Plus, they're all lab processes that we're going to be learning about for these separation techniques, and the movement on the test is to a more lab-based curriculum. So please realize that this is going to very likely show up multiple times on the AP test. So first of all, the idea is that we need to separate mixtures sometimes. It can be something as simple as the lab that you did last year, where you had iron filings and sand and salt and water and little seeds all in a mixture, and you had to get them separated. Or as confusing as it is for some, we could actually separate out a mixture of, say, I took rubbing alcohol and poured it in some water. We can actually get those two things back separated from each other, even though they make a homogeneous solution. And we're going to talk about different techniques to be able to do that. I'm going to take them one at a time in each video lesson so that it's easier for you. If you need to go back and watch one, it'll be easier for you to do that. Plus, each one will have a little short video clip showing you the lab process, actually allowing you to look at the equipment, because my descriptions and my pictures are good to some degree, but actually seeing somebody with the equipment in their hands will be beneficial. We're going to start this lesson, the first one, with filtration. The four we're going to be discussing, you can see here, are filtration, distillation, paper chromatography, and column chromatography. So let's go ahead and start with filtration. Now, filtration is the one you're probably the most familiar with. You did do this in honors chemistry with that lab that I was talking about, when you needed to separate the liquid solution from the solid sand. Filtration really just needs some basic materials. You need a funnel, you need some filter paper, you need something to catch the liquid in as it passes through the filter paper, and preferably a glass stirring rod. You may not have done this last year, but as you can see in this picture, the glass stirring rod, which is right here, is going to be an enabler to try to help the splattering from stopping. So you're going to be pouring your liquid out, and it's going to go down along that glass tube. And when it goes down along that glass tube, it's going to go into there more smoothly, as opposed to splashing all around. Because if you lose any, then obviously that hinders your results quite a bit. The picture on the right again shows the filter paper and the particles, and you can see why some particles pass through the filter paper while others don't. The holes don't allow the bigger particles to come through, whereas the smaller particles have no trouble passing through those holes. So just a couple of terms. The liquid that comes through the filter paper is called the filtrate. You can see it here. Okay, the filtrate. And then the residue is the solid that's left in your filter paper. Now, I'm going to show you a quick little video, and that video is going to let you visualize this, but again, I'm sure most of you even remember this, whether from honors chemistry or some other class. Hopefully we won't have trouble here. I've been having technical issues, but let's see.
You must have seen the use of a strainer to separate tea leaves from the brew, and a muslin cloth to separate juice from the fruit pulp. But do you know how undissolved solid particles are separated from liquids? Yes, through a sieve or strainer. The liquid particles are small enough to pass through the pores of the strainer, but the solid particles are too large, and so they cannot pass through. But what do we do when the solid particles are also very small? Well, we then use a strainer with even smaller pores, like a filter paper. Let us see how a filter paper separates undissolved solids from the mixture of wheat flour and water. We need a mixture of wheat flour and water, conical flask, funnel, and a filter paper. Fold the filter paper in the form of a cone and fix it on the funnel. Pour the mixture of wheat flour and water on the filter paper. Wait and observe. Look. Clear water passes through the filter paper and gets collected in the conical flask. The wheat flour particles cannot pass through the filter paper and remain on the filter. This is because the pores of the filter paper are smaller than the particles of wheat flour. Filtration is a process by which insoluble solids can be removed from a liquid by using a filter paper or membrane. In the filtration process, Liquid that filters through is the filtrate. Undissolved solid particles are residue. Now can you guess what you should use to separate, say, tea from the brew mixed with tea leaves and mud from muddy water?
Okay, so again, I know he sometimes was talking and his accent is different, and so he was saying things you may not have understood, but the terms are still the same, and I think those were clear. The filtrate, the residue, and then understanding the basic idea that you're trying to get two things separated from each other, but the key is that they weren't soluble in the first place. Okay, so that is filtration.